Hello, my name is Thorsten Balthasar. This video tutorial explains generally the major planning and process problems of infrastructure construction projects. You will get a fast overview about the benefits of displaying the schedule of such projects in a time-location diagram. The target audience of these videos are all people involved in infrastructure construction, estimators, planning engineers, project schedulers and controllers, students, technicians and civil engineers, in general all people who want to learn more about planning in time-location diagrams. At the beginning, just some words about conventional scheduling display. The network or PERT diagram displays activities in boxes and delivers the base for the critical path method, the common used method to calculate the shortest way in a schedule. The dependencies displayed as arrows are showing the process structure very nice. But as there is no direct visible relation to the time axis, the understanding of a network diagram is poor and abstract. Hence, there is a small usage of network diagrams in practice. Very common is the Gantt diagram. The Gantt diagram adds the horizontal time axis and displays each activity in a spreadsheet line. It has also a good presentation of dependencies and uses the critical path method. With its direct relation to the time axis, the Gantt diagram is the most popular display in project planning. But, especially for construction projects, there are some limitations that complicate the readability and understandability of a Gantt diagram. There is no visible relation to the location or building to be constructed. Especially large project charts therefore are confusing, unclear, or must be printed on lots of papers. So if we are looking at infrastructure projects, the question is how to display schedules of infrastructure projects. Pipeline, rail track, road construction, earthwork projects, tunnels, bridges and transmission line projects. All those projects have in common the activities are spread in different locations. The locations are defining conditions for the schedule. I would like to show some common location conditions along a road picture. Repeating activities on the same location are very common in infrastructure projects. Different layers of work are following each other, often with different speeds. For building these road segments, we have to cut the earth, compact the ground, then lay the base and binder course. Each activity is quite different, uses different equipment and is working in different speed. Another location condition is that you may have to work in different directions. That can be caused from access, logistics or organizational issues. On some sections, you may have different working speeds. That can be caused by elevation, material, machine or access width and quantities on that location. Very often you have to work on different locations at the same time or dependent on each other. There is also restricted access to the site coming from right of access, right of way, possession times or environmental protection instructions. There are lots of logistic activities to transport material, equipment, masses. Very often there are additional location and process conditions when specific construction phases and states are defined for a location. Or the construction process has to swap to the other side due to traffic redirection phases. As a result of all these conditions, there are many possible conflicts and clashes that have to be included in the planning. So the question is, how to plan and display all those movements and location-based activities in a Gantt diagram To be honest, even the commonly used possibilities of coding and grouping activities in a Gantt diagram does not give much more understanding of the project schedule. So let's add to the time axis in Gantt diagram a right-angled distance axis. Very common is to display the time axis vertical and the location axis horizontal. The sitemap is added alongside the distance axis to check the location of an activity. This little animation is to be explaining the idea of planning in a time-location diagram. While time elapses, you see different activities developing on different locations. The lines are moving activities, while the rectangles just working on a static location. You can see different locations under work at the same time and also activities with different speeds and directions. So, what is the information displayed on a time-location diagram? Such as the Gantt diagram, it displays start and end date and the duration of an activity. Additionally, it displays start and end location and the length of the activity. Combined with a site plan and a scale of important points, the time-location diagram produces a direct reference of the schedule to the activity location on the site. The time-location diagram displays the working direction of the activity. And it displays the different working speeds on the activities by a different slope of the line. Conflicts and clashes between activities get visible by overlapping of activities. Even possibilities for solving such conflicts are visible. In this case, just the direction of the two lines are changed to avoid the clash on the location on the rectangle activity. In the following, I would like to present some easy common linear processes. The first is a simplified pipe laying process to show the calculation of lags between repeated activities. First, the trench is to be opened, then the pipe has to be pulled down and bended. After that, the trench gets closed. Three linear activities that are following each other, but normally not as a finish-start dependency in the way the Gantt on the bottom displays, as there would be too much loss of time. In the time-location diagram, you may see that the blue and orange activities, pipe laying and closing the trench, could be moved up without crossing the other activities. This means they could start earlier. But do not move them too early, as the result could go to a clash. You will see the clash by overlapping activities. Here, this means that the trench closing activity has overrun the pipe laying activity. So here is the best result. After trench opening activity has reached some distance, the pipe laying activity can start. As it is slower than its predecessor, there will be no clash. The pipe laying task works slower than its successor, so trench closing is not allowed to start too early if you want to avoid a clash. The next sample is showing different possible reactions if the construction of a building interferes a line construction process. As you see, the blue line is coming to a location where some local construction is going on, displayed as the rectangle. For sure, you may move the building construction to pass with the line. You could also move the line, then passing the local construction. But sometimes this is not possible. Then you have some possibilities that can be displayed and explained very nice in a time-location diagram. You may stop the linear activity and wait till the local construction is finished. You may jump over the local construction and come back later to this area. And finally, you may move the whole equipment and do the rest of the line from the other direction. The next sample is showing how to avoid areas due to legal restrictions, access rights, environmental protection or weather conditions. As you can see, just 4 linear activities are planned for this area. But what if you have no access on specific locations at specific times? How do you have to change the schedule? The clue is first locating the blockings, then fitting the task in the remaining place. Sometimes you have to cut the process and relocate the equipment, but in some there is an optimized schedule still very near to the original duration. Coming so far, now what are the benefits using a time-location diagram for planning infrastructure construction projects? Starting with the obvious from time-location diagram. Not only you are planning the time schedule, but also location, direction and speed. You may foresee and avoid clashes and conflicts of activities working on the same location at the same time. There is a direct graphical reference from the schedule to the construction site plan. This is adding much more clarity and understanding to your schedule. The time-location diagram gives assistance in natural graphical planning based on the location. You may consider all project conditions coming from restrictions, weather conditions, processes and phases, and logistic and possessions. A time-location diagram is supporting you in presentation, explanation and readability of your project. Not even you can use time-location diagrams for planning and scheduling, but also for explaining the construction process, or considering all transportations and logistics. You may present the work split it in different project phases, or monitor and control the execution. Even use it for discussing about claims. Last but not least, compared to the anonymous and abstract Gantt diagrams, a time-location diagram brings more clarity. All involved people like planners, site managers, foremen, owners and the management can understand and will accept the plan. At the end, time-location diagrams are used, while big Gantt charts mainly are just looked at. I would like to thank you for your attention. I hope that you found this video tutorial about displaying infrastructure project planning in a time-location diagram useful. If so, please vote positive and share the video with other interested people. My name is Thorsten Balthasar and I wish you good luck with your projects.